Issac Newton is one of the greatest scientific minds in history, a man whose ideas were so powerful that they changed how humans understand motion, gravity, and even the colors hiding inside light itself. He was born on a stormy winter night in a tiny English village, so small and fragile that people joked he arrived in the world carried by the wind rather than by human hands. Baby Newton was so tiny that everyone feared he wouldn't make it, yet he grew into a boy with unstoppable curiosity and a mind that sparked like a hidden firework waiting to burst open. Newton wasn't the loudest kid or the strongest, but he had the kind of quiet thoughts that could shake the world if anyone ever had the chance to listen to them. He loved building wooden models of anything he imagined: mini windmills, water wheels, and even simple machines that clattered and whirred like tiny inventions from the future. Whenever people saw him tinkering with gears, pulleys, and bits of wood, they often said it looked like he was trying to unlock the secrets of the universe before he even learned algebra. Newton rarely talked about his emotions, but he wrote everything else down: ideas, experiments, strange questions filling notebooks that looked like treasure maps of his growing imagination. In school, Newton didn't shine at first. He was quiet and slow to show off his talents, just a kid who sat near the window and daydreamed about how the world worked. But when a class bully pushed him too far, something inside Newton snapped, not in anger, but in determination so fierce it could lift mountains. Instead of fighting with fists, he decided to defeat the bully by becoming the top student in every subject, and soon he soared so far ahead that his classmates could barely see him from behind. Teachers realized they weren't dealing with an ordinary student, but with a brilliant mind glowing like a lantern hidden inside a small, wooden box. When Newton went to Cambridge University, he found a place filled with books, ideas, and scholars who loved exploring mysteries just as much as he did. He studied mathematics, astronomy, physics, and even philosophy, collecting knowledge the way a dragon collects treasure, carefully, proudly, and endlessly. But just as Newton's mind was heating up with ideas, a deadly plague swept across England, forcing the university to close and sending students home for safety. While others panicked, worried, or grew bored in isolation, Newton used the quiet countryside to think deeper than ever before, turning his forced retreat into a legendary period of discovery. During these 2 years away from school, he asked questions no one else had asked, solved problems people thought were impossible, and planted the seeds of modern science. One sunny afternoon, Newton sat under an apple tree in his family orchard and watched an apple drop to the ground with a soft thump that echoed loudly inside his mind. Though the moment was ordinary, the question it sparked was extraordinary, making Newton wonder why things always fall straight down instead of sliding off to the side or floating upward. He wondered if this mysterious downward pull was the same invisible force that kept the moon circling Earth instead of flying off into endless space. From that single falling apple, he developed his theory of gravity, an invisible force powerful enough to guide the motion of planets, moons, oceans, and every pebble on Earth. Newton didn't stop with an idea. He built a mathematical system so precise that scientists still rely on it centuries later to predict everything from ball throws to spacecraft orbits. While studying light, Newton passed sunlight through a prism and watched it explode into a rainbow that painted the room with shimmering color. He discovered that white light wasn't too simple at all. It was a hidden mixture of many colors that could be separated, bent, and studied like a magical secret. Newton filled his room with prisms, mirrors, and beams of sunlight bouncing in every direction, creating what looked like a laboratory built by a mischievous rainbow spirit. He even poked his own eye with a needle-like tool to understand how vision worked, a dangerous experiment he later admitted was impressively foolish. Newton's passion for solving the impossible drove him to invent calculus, a powerful new branch of mathematics, before he even turned 25. He didn't brag or rush to publish. He simply wrote down the method quietly in his notes and then moved on, as if discovering a new math universe was no big deal. Years later, when others announced similar findings, Newton revealed he had discovered it earlier, shocking everyone and settling debates with calm confidence. Newton's greatest masterpiece came in the form of a massive book called Principia Mathematica, a text so rich with ideas it became the foundation of modern physics. In this book, he described his three famous laws of motion rules that explain how objects move, how they stop, how they speed up, and how they interact with forces. His first law explains that objects continue doing whatever they were doing unless something pushes or pulls them, which is why your skateboard keeps rolling until friction or a rock ruins your fun. His second law shows that force equals mass times acceleration, revealing why pushing a heavy couch feels like trying to shove a sleeping elephant across the living room. His third law, every action has an equal and opposite reaction, explains why rockets blast upward, why birds take flight, and why jumping off a swing sends you soaring backward in a dramatic arc. These laws became the unshakable foundation for physics, engineering, architecture, and nearly every invention humans created afterward. Newton also designed the world's first practical reflecting telescope, using mirrors instead of lenses to produce clearer, sharper images of distant stars. When he presented it to the Royal Society, scientists were astonished that a young man had built a telescope that seemed to pull the heavens closer to Earth. Newton spent countless nights studying the paths of planets and comets, uncovering the elegant mathematics behind their glittering journeys across the sky. He discovered that gravity wasn't just a force affecting apples, it was the glue holding together the entire cosmic dance of the solar system. Scientists soon realized that Newton wasn't merely exploring Earth. He was mapping out the rules that governed the entire universe. Despite his brilliance, Newton had a dramatic side, especially when debating other scientists or defending his ideas with fierce determination. His rivalry with Robert Hooke became legendary, filled with sharp letters, bold claims, and enough tension to fuel 5 seasons of a science-themed drama show. Newton could be sensitive to criticism, yet he also showed remarkable kindness to young scientists who sought his guidance. As president of the Royal Society, he helped shape scientific research across England while still chasing his own experiments and ideas. Later in life, Newton worked at the Royal Mint in London, where he hunted counterfeiters with such skill that he became one of the most effective crime fighters of his era. He investigated criminals with detective-level precision, collecting clues, interviewing suspects, and building cases with the same intensity he used when studying the heavens. Despite fame, power, and scientific glory, Newton never lost the quiet curiosity he had as a boy tinkering with wooden toys and windmills. He often said he felt like a child playing on the seashore, finding smooth stones and pretty shells while the great ocean of truth stretched out unexplored before him. Newton believed that no matter how much humans learn, there will always be deeper mysteries waiting patiently to be discovered. His discoveries opened the door to modern science, powering rockets, guiding satellites, shaping engineering, and inspiring generations of physicists. Every ride on a roller coaster, every flight in an airplane, and every space mission whisper Newton's ideas through their motion. His laws help video game designers make realistic physics, allowing characters to jump, fall, slide, and soar in ways that feel true to life. Newton proved that a quiet mind can be mighty, that curiosity can change the world, and that even the simplest moment like a fruit falling from a tree can spark a revolution in human knowledge. He taught us that asking, "Why does this happen?" is a powerful beginning, one that can lead to discoveries beyond imagination. Newton showed that the universe runs on beautiful rules hidden beneath ordinary events, waiting for someone curious enough to find them. His legacy glows across history, reminding young thinkers everywhere that science isn't only about formulas, it's about wonder, courage, and the thrill of exploring the unknown. Even today, students study his laws, marvel at his brilliance, and imagine him sitting under the apple tree with ideas swirling like galaxies behind his thoughtful eyes. Newton's life encourages every child to look closer, ask boldly, think deeply, and trust that curiosity, no matter how small, can change everything. Because somewhere, right now, a young mind may be watching a falling leaf or a bouncing ball, unknowingly standing on the edge of the next great discovery. And just like Isaac Newton, That spark of wonder might one day rewrite the way humanity understands the universe.